Okay, today we're going to look at something called the interquartile range. So I'll just take you back to remind you what range means. Range is normally the distance between the biggest and the smallest piece of data. So that's what range is, but we're doing something slightly different to the interquartile range. So the interquartile range is often shortened to IQR, and it is the difference between the lower quartile and the upper quartile, which you can calculate easily by doing the upper quartile subtracting the lower quartile. So now we need to work out what the lower and the upper quartiles are. So if I was to have a set of data, and I'm going to do it as an image of a box because it's easy to understand that way, the middle piece of data we should know is the median. So it's gone off camera. So the halfway point of between the median and the biggest piece of data, that is the upper quartile, the halfway between the median and the upper end of the data. On the other side here I've got the lower end of the data, the halfway between the lower end and the median, that is the lower quartile. Okay, so I'm going to pause there while you write those bits down. Okay, so I'm going to give you an example with just numbers to begin with. So this is my set of data, and this is obviously my lowest piece of data, and this is my highest piece of data. So we'd normally go through the process of finding the median by crossing off the smallest and the biggest, and the smallest and the biggest, smallest, biggest, smallest, biggest, till I find my median. Okay, so that's one's my median because it's one in from each side till I get to the median. Now, in order to find the quartile, I look over here. Okay, so I want to find the middle piece of data here, but I ignore the median and I then work out what's the middle here. So 3, 12, 6, 9. So my halfway point is halfway between 6 and 9. The easy way to do that if you're getting confused is between 6 and 9. Halfway there is 7.5. So that one is my lower quartile. So I'm going to go again, ignore the median, go here. So my halfway point is there, they're coming to each side. So my upper quartile is 20.5. So that's how we do it with numbers. It's also possible to do in a table and a stem and leaf. So as we've been recently doing stem and leaf diagrams, I've got a question here for us. So first thing I want to do is calculate the median. So I'm taking off the smallest and the biggest, smallest, biggest, smallest. Careful, we've got to go here for the biggest. Smallest, biggest, smallest, biggest, smallest. There for the biggest, smallest, biggest. So this one is my median. We have to be really careful not to get caught out at this point because this is not 4, it is 14. So my median is 14. Now I want the range. Again, we've got to be careful not to get caught out by a stem and leaf. This is 2, is 0, 2, so the lowest number is 2. My biggest number is not 5, it is 45. So I'm going to do 45 minus 2 to get my range, which is 43. Now I'm going for my lower quartile, so I ignore the median, and I'm going to change colours to help it stand out a bit. So I'm going to take off the smallest and the biggest, and the smallest and the biggest, and the smallest and the biggest, to leave my lower quartile is this represented here, and that is 0, 4, so the lower quartile is 4. Now I go for the upper quartile, so again we ignore the median. So I'm going to take off the biggest and the smallest and the biggest and the smallest and the biggest and the smallest. This digit therefore represents my upper quartile, but it's not 4, it is 24. So the upper quartile is 24. Now calculating the answer for E, calculating the interquartile range becomes easy. It's 24 upper quartile minus 4 the lower quartile, which gives me 20. Okay, thank you.